Good morning, good afternoon, good evening. Welcome everybody to today's session, CI/CD with OpenShift and large, highly regulated enterprises. We are hosting two sessions on this subject, the first one today and the second same time Thursday next week. In today's sessions, we will showcase how to build a microservice-based application with OpenShift. In next week's session, we will automatically create a stage environment with a custom Jenkins pipeline out of OpenShift. Our speaker today is Felix Knöpke. Felix is an experienced solution consultant with a background in PaaS and SaaS solution design. Prior to T-Systems, he worked for various Berlin-based PaaS startups. For those of you guys who don't know T-Systems, it's the corporate customer unit of Deutsche Telekom, one of the largest telecommunication companies globally. A few logistics before we get started. If you have any questions during the session, please submit them via the text chat as we go. Felix will answer them at the end of our session. This session is going to be recorded and we will send out the URL within the next 48 hours. So without further ado, let me hand over to Felix. Felix, the stage is yours.
Thanks. So welcome to all attendees here. And yeah, you introduced me already. I have nothing left there. If you feel questions, please ask them the time you have them, that you do not forget them later on. So it would be easier to just have the case to respond on later. I know that I will cover some topics and it's easy to miss a question later on if you don't ask them directly. So I just want to open with my agenda. And I want to talk about the scope of the whole session, which means the scope of both meetups. Then I will introduce to you our sample application we'll cover today. Then the methodologies we're going to use to build up our microservices-based architecture. And then I will just directly jump to the live setup and you can follow me on doing all of those steps. Finally, we have the Q&A session where we'll respond to all of your questions. And well, yeah, so it is. Day one of our session is today. And today we will set up the microservices-based sample application. And we will use a lot of different deployment methodologies, how to put all of those containers on our platform and yeah, connect them to each other. On day two, we will continue working on that application, but what we want to do there is to initialize a pipeline environment, set up a new stage via a pipeline, so a whole copy of all of those components we deployed once in a single click, that we do not have to build up everything in tiny bits again. And then later on, we can also create a pipeline to move single application parts of those microservices-based application via pipeline to the new environment. So we have to cover a whole staging environment and how to develop single applications there. If we're free and have time left on day two, maybe we can cover some of the parts you're interested in and we can do it by a response. So our application today is the so-called SOX Shop, which is a microservices demo application by Weaveworks. Weaveworks just took, well, so to say, a shop application, an e-commerce application, but scattered as many microservices as humanly possible. It has solely the purpose of showing the power of microservices or showing different things, how to interact with microservices application. And since it's a third-party developer who had never OpenShift itself in mind, I found it's a very suitable solution to showcase the power of our platform without taking something that was purposely made for OpenShift. So yeah. The documentation of all steps I will do today are documented in our own GitHub microservices CI/CD GitHub organization. The purpose of that is, of course, there is an own GitHub version of the microservices demo, but we had to do some minor changes to make it work with OpenShift, of course. But in order to just change source code, change tiny bits, we didn't want to make pull requests for the main project, so we just did a fork of that, and that's what we're working with. And also we just added all of the documentation for our demo example here. Why this application? As I already said, it's a third-party developer with an own purpose. It was never purposed for OpenShift, so it's independent example. Also, we can explicitly showcasing the microservices architecture. A lot of you were probably interested in, and also our microservices, the power that you can just build up on and PaaS application or PaaS platform like we have here. Third, we have the code base of that application, which is quite state-of-the-art. So we use Go, we use Node.js, we use Spring Boot, and as I know from my experience with a lot of customers, I know that those are topics some of you are really interested in on how to cover it, how to use it, and how to build applications with it. So how does this application look like? So normally we have a front end, a back end, and maybe a database. Here it's a little bit more scattered. So we have still a front end, which is our web shop front end. We have a catalog and a catalog database, which just cover all of the, well, product items and so on. And then we have all the checkout pipeline, the order mechanism under the order component, which again has a lot of subcomponents, which is like cards and cards DB to just save and process the cards and checkout pipeline. We have the orders DB to just have all database elements for the orders itself. We have payment methods and processing by a separate component, the shipping by separate component, and we have a queue master managing our RabbitMQ where the source code is running. Why such a lot of microservices, you are asking, maybe, if you don't know why you should like scatter up an application like this? Well, it's easy to develop in different core teams, different application components. If you have everything in one single application or component, it's from time to time difficult to respond on like changes or to like release new features. So you have to wait for other teams, for other developers finishing their work, and then you maybe are forced to do major releases because it's a huge step to bring all of the new features at once, because you do not want to update the same component all over a day so often. But in that kind of architecture here, you could just replace a single component and that team-based. So you have all the members that are working on a project, and normally also all the operators. So the terminology is DevOps. You build it, you run it. So in that terms, you can just update your application multiple times a day, and you just replace different parts and different teams working on it. And it's easy to maintain, to keep in a nutshell. So as you see, I also added little icons which indicate which kind of source code is used here. And for different kinds of technologies, we use different methodologies to build them up. So also, the application has the possibility of a scaling front end, so that if we scale out the front end itself, we need to store our sessions in an external Redis DB. Normal in the simple setup we will do today, it stores everything on a local memory. But if we have multiple front ends, we would have different sessions for each of those front end components, and to have the same session over all of those three, we store our sessions in the central Redis. So that would be the final deployment. And let's see if we can add the scaling functionality on the second session as well. What are we using to deploy? I will go more into depth in my demo part, but to just showcase in a nutshell, we have our built-in catalog. So you can just search for specific images you want to deploy, select them, deploy them, and you have everything running. And it's like a candy shop. Select a suite, put it in a bag, take it with you. In that terms, we have in our portfolio or in our catalog already a variety of different services we can just pick to have it run for our application. We will do it for databases. I will show you later. Then we have the source to image. The source to image is the biggest power of OpenShift because it has multiple possibilities for developers. Normally, a core developer just sees its own source code and is working with it. Normally he doesn't or hasn't got any interest in how to operate it or how to run it and what's necessary, but he probably knows because he's building it. So in this case, in order to run it and test it, he just needs to know his source code and which kind of environment it does need to run in. So he codes, he just pushes to GitHub or any repository he is likely to use. Then you can use the repository to trigger the application. We can force it manually, but in the final evolution, you can just trigger the OpenShift platform itself that there's that we have like a trigger URL. Maybe the work is coming later. So we trigger the OpenShift. So OpenShift is forced to check out the source code, and then it will grab one of its source code environment or source code native environments as image from its own repository. So we have for a PHP, it would be an HTTP. We so installed PHP. We would have the web server and everything else. And there are also some scripts, for example, to just put the source code in the right directory, like the www folder, and then the script that tells the platform how to run it. So everything we do here is take our environment native image, take the source code of the developer processes to one central image and store them again as image, but also deploy them. So we take that image and create a container automated from there and put it on our worker nodes. In that case, as soon as the developer hits the push button and pushes its source code to a specific tag or the master branch, something like that you configured, the whole pipeline or chain is evoked and the image is put on the platform by itself. That is a very neat procedure, and the developer, as I said, does not need to know how to run all of those source code itself or how to install a server or something like that. So the automated way of code build deploy. Then we have, last but not least, for several purposes, there maybe are not any builder images available. So the builder images are the environment image with the source code native packages installed. Sometimes you really need to kind of install the server on your own, but you might have an idea how to use it, or at least the internet doesn't know how to do it. So in this case, you can write a Docker file, and you can just add it as please build me that image. And normally the platform will scan the repository itself and try to find any kind of hint on what kind of language it is. And maybe if it finds an index PHP, it would default to, well, it should be in PHP, try to use the PHP builder image. But in case of there is a Docker file available in the repository, it always will default to the Docker file, because the Docker file is a manual on how to handle your application or how to handle the source code in here. So it will build the Docker file to an Docker image, and then deploy that image on the platform, as well as storing the final image in our image stream. So that's just a little introduction on what we're seeing today and what we're going to do right now. So make it small and going here. So what you see here is the OpenShift environment or the OpenShift interface from the web UI. What I will also use today is the command line. I have installed here a git bash, which will behave as a bash on Windows, which is very comfortable if you're working with a Windows PC and trying to do something on the console. Installed on that git bash is the OC client. The OC client is like a command line interface to the OpenShift platform, and as well as the web UI, it will talk to the API. The command line interface is a little bit more powerful. It's scriptable. You can do anything you want with it. The web UI is a little bit more nice to look at and to see metrics, to see statistics and stuff like this. We will use both a little bit today. So today we're solely working with the dev environment. I created a project the CI/CD demo environment for development. And we'll start to add projects here. So as I said, we have a microservices repository, and you can find anything I will do in that repository. So just go to microservices-CI/CD/pipeline, which is a repository for all the pipeline scripts, and in the README ND you will find all the steps I will cover today. Also, we have in the core organization all repositories belonging to what we do right now. So we have all the microservices as source code available, and we will use them as well for everything we do today. Okay, so as you have seen, some of the like microservices are very similar to each other. So I will take the first four of the like microservices and explain them a lot while I do them. And the last one, or all the rest, I will do more quietly in a rush manner to just deploy them to see something in the end. But maybe I can tell in short way what I'm doing then. And well, I could already start to answer questions there. And what we want to start with is the CardsDB. The CardsDB is like a MongoDB service. And it's very easy. We only need a MongoDB, nothing more. Everything else is done later on. Also interesting is like I have something available in my OpenShift environment. So I just go to Add to Project, and I just browse my catalog. So in my catalog, I can then just search the term MongoDB. Here I can choose, maybe for later on, I could choose between several languages. I could browse several middleware technologies, data store technologies, everything here, and I can deploy them myself. The easier way, if I know what I'm looking for, is to just type in the filter, and it will just filter all the items I am looking for. And I mistyped. So down here at data stores, I have my MongoDB examples, and here are always two opportunities possible. We have the ephemeral and we have the persistent. Since we're using containers, and a container is considered as a stateless application, we need to care about our storage, because as soon as a container finds or has any error going on, it's killed by the orchestrator, and a new image is the image is taken to spawn a new container. So every temporary or local data that is written is gone after that. And well, after that, there would be a new blank database. That's what happens with the ephemeral. So it's called in local memory database. Then we have the MongoDB persistent, which just indicates that here we have some extra storage we can mount into the image itself. So it's called persistent volume claim. So as soon as an image or a container will claim a persistent volume, it just labels it as that's mine. Here's my name written on it. As soon as I'm crashing, no one can take that persistent volume because it's mine. And as soon as I will come up again, I will grab my persistent volume and mount it to my data file system so that I can use my data later on. Since that's just a demo example, I will use the ephemeral storage, but just for you to know, that's the both opportunities. As soon as I'm here and the documentation tells everything by command line because it's a way easier way, I will show you here in the web front end how to do it there. We have several parameters like how big should the database be, which is much more important if we are using persistent volumes because we need to decide how big of a volume we need to mount. Here it's secondary important. We just use 512 megabytes. Then we have like the namespace from where we're taking the image from, because everything we see here is also just an image in our repository. But we're taking, we have a template that is telling me, well, give me some parameters and I will deploy your customized image. It's nothing more than that. So that's just the space where we store the image. We could also leave it out because it's not important for you to just change something here. But now we get to the more interesting things like the database name, the database service name. Here we are talking about the cards DB. We have the username. It's like very simple: user, path, data. We leave the admin password empty, so there is a value generated for us if we do so. And we stay with the 3.2 version. Also, we will add some labels. If we don't add the label app, we will end up with the default value for MongoDB ephemeral. So we will see it as MongoDB ephemeral. And that's why I'm just adding like my cards DB here. Also, I will add another label, which is stage. And I call it dev. I will label all microservices with the label stage dev because I could just perform actions based on labels later on. And so maybe if I want to delete things, if I want to tag things, I could select everything with a label dev and do something with it. So it's easier to maintain specific applications. Also, that's why I just added the app label, because I could also delete specific apps with all resources attached to them by just selecting a specific label like app cards DB. Why that's so important? OpenShift itself does create a lot of configuration items itself later on if we just create an application. So we have like the deployment configuration, root configuration, build configuration. So a lot of different parts of code that are scattered around the Kubernetes, which is one of the core technologies behind OpenShift. And so with this label, we can just aggregate all of those several configurations later on to maintain them way more easy. That's why it's important. And then I will just create a database. And after I did create the database, it does spin up. So here it's just telling me on how to log in it. And we see that there is the first item coming here. And give it a second, and it is starting. It's now ready, and some more. We can also just track all the events that are happening under the hood by looking at the events. So it started the container, and now the deployer pod is killed because the deployment finally is started. And now you see unhealthy because there is a readiness and a healthiness probe. So as soon as the container is starting, the probe is fired. It's not ready yet, but some seconds later, the service was ready. So I go back and we'll see that there is everything running and fine. So far, so good. We have a database. So going back to the documentation, and I will go to the cards application, which one is using later on the cards DB, of course. And we have a Java, a Spring Boot Java application. What we are doing here, let me just increase the size a little bit for you. I think it's easier to read. So we have the cards application, which is using the OC new app command, which just says, well, create something for me based on some information I will give you. It's the same as the template we used earlier on, just with a difference that I have to tell what kind of parameters it has to take. So here I need to know a little bit better what I'm dealing with. Also, I'm using a builder image. That one is a builder image which represents an OpenJDK Java environment, specific made for OpenShift, which is like a plain Red Hat Enterprise Linux with an installed OpenJDK image. What we're also doing is taking the application source code from our repository I told you earlier on, and then build an so I'm not a Java expert to just tell you earlier on, but we build in WAR or jar file. Not exactly sure what exactly is built, but then fuse the jar file to the OpenJDK and then deploy that final image to our environment. We also give it a port which it is using, and we tell it how to access the database. And that's just the user and password as at cardsdb, which is the service name I gave it. So in our cluster, we do have a software-defined network, and the software-defined network is using service names as like a DNS or for DNS. So a service name is like a unique URL. Also, we give it the name or the label stage dev, which has a reason what I told you earlier on. So I go to my shell, and well, it didn't copy. So here we just insert our command line or command in the line. And then we should see that something will happen on our platform, that we do create a new build, and voila, here it is, a new build is triggered. So the difference between the first one we deployed and the second one is, with the first one, with the database, we didn't need a build because, well, the image was already existing. We just took an image and parameterized the credentials here. The second one is a full build process. So the first thing we do, we need to build our final image. And as you see on the right side or on the left down here is like we're executing a full Maven build. We can also directly jump to the building pod. So we started an own pod or container to do or to execute the build process in it. And then we can just follow everything he's doing to see what's happening. Now he is just downloading all the resources. And if we have our final binary, we will just put it in the image, in the environment image, and then wrap it together and upload it to our repository again. What we can see here is what different kind of resources are created. We have here we see the build itself was done, the Maven one, and now he's just wrapping the image together. But we see we have the build configuration. Where do I get the source code from? What do I do with my source code? Then we have an image stream. An image stream is like a tag or an element where all of the images I create for a specific service, like the cards one, are stored into, like a kind of versioning for all of my images. And as soon as I build a lot more of the same applications, later on I can see different entries, different older images. And the last one has, of course, the tag latest, or the latest one has the latest tag. But if I deploy at any time or point in time an image which has an internal error or something going wrong, which my test, unit test, etc. didn't catch, I could just revert to the last image. So that's the core benefit of having my or those image versioning underneath. Also in applications, we see there is a deployment configuration that tells my platform how to deal with the final image as soon as it has been built. So where to deploy it, how to deploy it, like all the health checks, auto scaling processes, etc. pp. So everything is controlled here, and I won't go into detail because it will catch a lot of time if I will do so. Then we have the services. The service, as I say, is a specific name for my application internally, but it's not the pod, it's not the container. The service itself can contain multiple pods as soon as I scale my application horizontally. For example, earlier on, I showed you the example of what I can do with my application with a front end later to have it scaled horizontally. It's 3 times all the same image, but I just have it or have the load balance between all of those 3 images. So that's the thing I can do with my deployment config to say, well, I would like to have 3 instances running, but for all of them, I will have the same service name, front end. And I could address internally with my service name front end to all of those 3 pods. And as soon as a request hits the service itself does the load balancing between each of those 3 pods. So you can take it as a load balancer. It's a very important component in all of the structure. Then we have the routes, which is like the possibility to expose to the outside. Here we have no routes because we do not want to expose that specific service to the outside later on. The only service we want to expose is the front end. So that was a little excursus about, or a little showcase about what all is done with the components I have here. And I see my application just started. And now I can go to the pod itself, which is also a component that is created, and go to logs, for example. And well, I can go to the top. I see, well, it's a Spring Boot application. It just started and is running right now in its native environment. Also, I can see, well, what events happen. If I just waiting and waiting for the logs to appear, but nothing happens, you will find at 90% possibility something here in the events, like he is trying to pull the image, he is trying to put it on a specific worker node. That's what is happening here or shown here before the pod itself is started. So, well, keep a look onto the events. The log I showed. You can also go to the terminal to go to an interactive terminal into the pod and like explore the folder structure and find data, etc. Like locating something, and you have the metrics to just check very shortly about the core metrics like memory, CPU, network load. In possible later webinar, we could also cover the possibilities of metrics in Agile with Prometheus and Grafana as our own internal metric solution, which is way more powerful than the built-in metrics of OpenShift itself. Okay, so now we did build the application, everything is running, but since we have no front end yet, there is nothing to show application-wise. So we just do continue with our application parts. We have the next DB, which is a MySQL DB, a catalog DB. The difference here between the cards DB on top is that this DB just needs to contain some sample data. And the data is available in a specific SQL dump file. As easy as that, but if we start the database and create an image, we probably will need the database to contain all of the data already. So what we did here is to write an initialization script, which we just put into the repository itself. And as soon as, so we have the opportunity to, or the possibility to use an MySQL builder image to create an image based on MySQL, which is populated by data already. That's what is done here. So every modifications that we did to the original repository by SocksShop, by the Weaveworks demo example, you will find all of the links I will show here later on in the information we send around. So every change that we did to the origin repository, we will cover here, like the modifications to just pre-populate the database and use it from there. And then we also still have like the simple application or command to create it. With the difference here, we just select that we want to have MySQL in 5.7, and we will add that source code to it, which just contains the initialization script. And then our final image is built with a pre-populated database. That will make sense for ephemeral database. Maybe if you have later on a persistent volume database, it does not make any sense anymore because you do not have the data in container as we do have it right now. So we could go back to our command line interface, paste it here. Still, we have the label dev. We have our credentials. Maybe interesting for you, later on, we can also use config maps or even secrets to store like credential information. And in our environment variable, we just point to those elements that he could take the data from there. So it's not exposed to anyone working with data, because it's bad practice, and that's where the elements will come to play and have its purpose to just keep credential data central stored, but not freely available. So it would take a second again until the database is finally built and started, but it's just an initialization script, so it's a very quick build in this case. So again, you see we're cloning the repository in the build container, and then the scripted procedures will happen, which is like it will find our init script, execute the init script, and we'll go from there. And soon we are pushing our image to our registry, and then we're deploying it from here. Correct? The next one is Go. A Go image is like a little bit different, because we do not have like ready, proven, or available builder image for Go images. That's unfortunate, but what we can do here is using a Docker file, because everything of our platform based also on Docker. So we have in the very core, it's Docker. On every worker node, there's a Docker daemon installed. On top, there's the Kubernetes of like orchestrating everything. And on top, there's the OpenShift interface and API that unifies a lot of functions and makes it accessible or accessible. So, well, it's native to our environment to use a Docker file. And as I said, as soon as a repository contains a Docker file, our builder logic will always default to using Docker file to build images. And we needed to do some little changes to our environment. What we did is to change the Docker file, because the core Docker file in the origin repository just contained all of the like security policies that are changed, but the OpenShift from Apigile, or the Apigile environment, does not allow a normal user to change security policies. In order that we can give our SLA, in order that we can operate the whole platform and make it secure for you as a customer and also for any other user, we have strict policy rulings about security, which will not allow the user to change those policies. So we needed to change them and make it run that way. So just for you to know, you are not allowed to run any image as privileged user. You are only allowed to run applications as unprivileged user. And so even though you have like the Docker hub available to take any image from out of there, some of them won't run because they are just run as root. So to create the app, it's a very, very simple command. We say just OC new app, give it a name, give it a repository, and give it a label. So we do not specify which way of building the platform should use. We just give it a repository and we are scanning it. We could do that way also with every other source code alternative. And well, sometimes the logic does hit directly the sweet spot. Sometimes you probably will need to tell which builder image it should use. So this command will take a few seconds, because now he is checking out the repository and scanning it through to just determine which way of building it will take for later on. So yeah, I think after that I will cover the source to image build once more in application with the Node.js version. Then you can see, well, it's as easy as that also with the own catalog in OpenShift itself. And after that, probably I will just go through all the motions that I explained early on, because now it's repetitive. So I do not explain everything in detail again. The only thing I think is that I have to wait for some seconds probably, because, for example, this thing, we need to scan some repositories and then it will continue doing stuff. Maybe I can already start with the front end on the page itself. So what we're trying to do here is like doing a Node.js. So let me see what I have available here. I go to Add to Project, browse my catalog. And then I will just go to JavaScript because Node.js is based on JavaScript. Let's see what builder image we have available right here. And there is a Node.js. Here I can select the version of Node.js I'm using. And then I can just take the repository from here. So here it is also using the Node.js 6 image. We give it the name frontend. I will do so as well. We will using this repository. If we do not enter a specific branch, it will always take the master branch. And I need to remember to take the environment variable port 8080 and the label stage dev. So as easy as that. So this builder image, select it, give it a name. We said it's front minus end. Give it a repository. Normally it would be that, but now we go to advanced options. So here the reference branch is master. I could type master as well to just be sure. I can specify everything I can change later on myself. But I will go to the bottom. There's the labels. With the labels, I have stage dev. And then I will look up the environment variables. We have build some that will trigger while building, so they are available within the build container. And we have some those are contained in the deployment config. Those will be available for the final image later on. We will take them for the final image later on. But for some Java builds, for example, it will make sense to have specific environment variables available via Java build. So here the variable was port 8080. And I guess I've covered everything that is in that command. So you see how it behaves in the platform itself. I will just click create, and that's what's done. Like we created a source to image build. Let's see what happened here. Okay, now he said he found Docker image. It's a little old from Docker Hub for Golang 1.7. So he explicitly took a Golang image, and then an image stream will be created, Golang 1.7. So we have Golang available in our platform. So every following Golang application I will build here is way faster because I have that image stream available. And well, he is creating the resources or resource and building everything that I need here. So if I go back to my environment, I will see that some more application parts have been triggered. We have the front end, the build is running. We have the catalog, the build is still running. Okay, so now we could follow. Here he is installing some packages for Node.js. He is also Go package fetching. So far, so good. And well, I think now I can continue in some kind of quicker manner to go through all the motions. And I think now is a quite good moment for Raphael to pick up the first questions that I can respond to the first questions while I'm doing the motions myself.
Yeah, sure. Thank you. Thank you so much, Felix, so far. So let me start with a question, which is, where can I download the client tool?
Well, there is an interesting fact, like we're using OpenShift Enterprise. OpenShift Enterprise will like bring you to a web page where you need to log in with your Red Hat credentials, which, as probably our customer, you won't have any because any Red Hat resource is available to you via us as vendor. The interesting thing is that the command line client is the command line client is also available from the publicly available OpenShift origins Docker, Docker repository, and you just need to look up OC client origins or origin, and then you come to releases. And here you find any release for OpenShift client for each platform or OS system. Keep in mind that the version corresponds to the version of the platform itself. For myself, I'm using the 3.6 version. Our Apogee is always a little bit behind the normal release schedule of Red Hat, just because we do like security testing, security approval from our platform team, from our security team. So we just count on stable platforms, and some of the newest releases of Red Hat tend to be not as stable as needed. So we just try to be as quick as possible, but also just take the stable versions. But here you can go to text, and with the text, you just go down and look up the right version. Here, there's the version 3.6.1, which will correspond to my platform. Then you can download it, and in my case, I just put it in a specific directory, add it to my bash profile, and then I have it available in my git bash. So I just created the database. Are there any new questions so far?
Yeah, there's a couple of you. So for all other guys who are participating in the session, feel free to ask your questions now. We'll keep the Q&A session open for the next 15 minutes or so. So the next question is, how can I directly work with a database? How do I connect to it from my laptop?
To connect it, so can you again put that question? Give me that question.
Yeah, sure. How can I directly work with a database? How do I connect to it from my laptop?
So there's a possibility to, on the one hand, like expose your database to the outside, then it's just a publicly available service. You have a route, like a web URL that you can just access, which is, well, if it is a critical, resource, not the best option to interact with or to expose it to the outside. But it's a possibility to just interact with the database as normal web service. On the other hand, you could just use the OC client to tunnel into a container that is running on the platform and use it as jump host. And then you can just log in from there into the database. Maybe you have like a client to execute MySQL commands there.
Okay, so the next question is, can I use Nexus for my Maven builds as a reverse proxy to speed up the build process?
Yes, of course. So that's already a best practice to use Nexus, because the bad thing with builds on OpenShift is that we use a new container for every build that is triggered. So there is no temporary files. We just can take ourselves and reuse them. So we always have a blank environment to build images in. So from time to time, it tends to take longer if we build, for example, Java, where it feels like we're downloading the internet. Their Nexus is very handy, that we can just create a Nexus, configure it as proxy repository, and just downloading all of our content through Nexus, and then taking it all from there again for the next build. So it's way, way, way quicker than going through the internet directly.
Okay, so the next question is, can I see the values of the environment variables I set during the deployments? And shouldn't I encrypt the database passwords?
Yes, you could see the values of the environment variable. So I just created the, what should I create? I think it was a Node.js with the fitting thing. So here's a front end, and I could go to my deployment configuration. So I add those environment variables to the deployment configuration. Here I see everything I triggered, there are pending things. So go to the front end. And within the front end, I go to environment. And within environment, I can see everything that is put here. But besides the simple environment variables, I have a couple of more options available to me. One thing is secrets. I can configure my own secrets, which encrypt password information. So I can create a secret name, tell it which kind of authentication it is, and then, well, keep it as encryption. That's very handy if you use, for example, SSH login to your repository, like source code repository, and you're only allowed to access code from there with an SSH key. You could put your SSH key here or use basic authentication for that kind of services. And then we have the config mats, which are the replacement for environment variables if you have more sensitive data there. Come on. It's a little bit laggy right now, I think. Yeah, well, my system isn't handling the streaming and the doing at the same time. So here is the config map. I could create a config map, give it a map name, give it a key, and then chaining some items here. So I could add item, and so for each value I put in here, I give it a I enter like a key, so it's a key value storing that kind of, and the values are encrypted later on. So I reference a key, and then the value is taken.
All right, we have one question left. Do I have to change to user 1000 in my Docker files?
Again?
Do I have to change to user 1000 in my Docker files?
It would be great, as I said that there is no user is allowed, or there's no privileged user allowed. And after 1000, I think it's the open user range that it was always great to reference to a specific user ID that is 1000 or above, and well, build images from there, because then we run as an unprivileged user.
All right, so that's all the questions that we got. Thank you so much, Felix, for today's demo and presentation.
Well, the demo is not fully over. So we just put the questions here while I'm doing some well, just doing steps. I want to show the running application later on that we just built something functional and not like executing some commands that look fancy but doesn't do anything later on. Because it's very repetitive for some of the users, I just tend to answer questions during that period of time. So now I'm coming to the end of everything I do. And as you have seen, the last thing again is a Golang application. And as soon as I hit, please build me some Golang application, it's just finding an image, doing it. So we do not wait so long as the first image. So yeah, we have a quicker pace here. And well, now we need to expose a deployment config to 8080. And then we're done. So what we can do now is still patch our service ports. So some applications tend to run on port 80. We normally need to tell them to run on port 8080, but we want to expose them later as real port 80. So sounds difficult, but the ports itself run under port 8080. The service that will be available as a load balancing and DNS resolution has its name under port 80, but talking to the ports behind itself, again, via port 8080. Sounds strange, I know. it will take a while until all of those commands are went through. And last but not least, we will expose our front-end service. The expose command just covers, please create a route for me to make it accessible from the outside, which I will do now, like please OC expose service front-end. What? The route already exists. Why does it exist? Well, okay. I know why it does exist. So per default, if I execute commands by command line, it's very explicit. Just tell what I'm telling you, nothing more. If I'm doing like the template from above, because the front end itself, I took the Node.js template from here, and it's very easy because the template just tells, well, if you create me as a Node.js application, please expose me. So it's automated in that term. So let me see down to front end. Here we have an exposed service. So there is a route. Let me go to the configure elements routes and front end. Well, you have the name front end and there's a host name. So our HA proxy, which is our router, does know the generic URL of our well, application. It's called the application name minus environment or project name, which is mcicd minus that, which is .add environment name. AZP18 means Azure Platform 18, which is my pre-sales environment where I do showcases on. And so that's where my route is accessible under. But later on, I can create an additional route, which has my very own URL. So I just do a CNAME on that URL with my specific domain, like sockshop.apigile.de, and that will just point to that by CNAME to that URL, and then we can resolve to the sockshop.apigile.de, for example. So we have our route here. So we can just try to access our service. Let me go down. A little bit unresponding, my front end system. There, the front end is. Give it a second to appear. Come on. So there's a link. And now it's loading the first time and our sock shop is available. Okay, let me go to the main documentation of the project, because there the users or the quick start just contains the user account I will use, the user1. Well, that's easy, user and password. And let me try to log in to see, well, if everything does work. Okay, maybe we didn't populate our database, but let me see to create another one. Username, email is user.name@mail.com, and password is password. So let me see if that is working. Okay, maybe there is an issue with our database. We would need to find out. I would consider on trying it after the session itself to see what went wrong, which is unfortunate because in my earlier testing, everything went through. Oh, there is still a build going on, the users. So that might be the cause. I was too impatient. Okay, so are there any additional questions in the last couple of minutes coming in?
I don't see any questions right now, Felix, but for all those who are attending us, feel free to ask questions. We have still a couple minutes left.
Okay. In the meantime, I just look up which component is pending. I think the users is the last one pending. So I guess the user was, let me see, a Golang application with, I guess, some resources to be downloaded. Well, yeah. So just let's give it the last seconds. Follow the build. Enjoy the logs. To see when I can check again. So again, as I said, in the next week, we will focus about how to go on. Now I finally built my application. I have a working state. How do I go on and create a pipeline? How do I create stages to go on from there and check all my projects? How do I orchestrate my teams doing that, etc. So that's what we are focusing from there. But I wanted to show to you today how easy it is to use OpenShift to deploy a microservices-based architecture with a lot of different components in no time. I think, well, that was 1 hour. Of course, I spent some time on investigating on how to do it, but you see the building process and bringing source code on my platform is kind of easy if you know how to deal with it. If you don't know how to deal with it, there's always assistance. We in AppAgile, we have a squad of DevOps engineers who could assist, for example, in such kind of work. If you say, well, I'm trying to just bring my application on a platform to make it run as a microservice-based application, but I don't know how. Don't know how. Then please ask for assistance, and there will be someone who could show you best practices using that platform, best practices of transforming your application into microservice-based application, and so on. So there's always knowledge available. Use it, and then you're fine. And I'm really asking why it does take so long to just build an image. It's a big component. So yeah, still no questions, I guess.
No,
Everything
we
is.
Everyone is
intensely waiting for the final application. Yeah, well, we need to be patient. Normally, the track I will do in those both days is well outlined as a whole day workshop with, well, let's say a couple of more bits that we do, like the scaling out scenario, load testing, how to perform load testing, how to do metrics on that thing. So it's, well, so to say, use case that we can expand a lot on, and maybe we can take that use case also for further web meetups that you do not discover every time a new environment and setup, that we can build on top of that, and then there's a whole picture of how to do that. And well, you just attended a whole day workshop in small consumable portions. So now we see the build itself finally completed. We're uploading it to our registry. We're nearly done in competition for the registry itself. Some more seconds, and then we see it getting deployed, and then we finally can use our users module, which is working then. So. Finally pushed. Image stream created, image stream updated. Then we go to deployments. Wait until it has been deployed. One active replica running. Well, now it's active. So let's go back to our, well, sock shop. Log in. I just update it once more. Loading. So there it is. Login, user password, login successful. Redirect. And here I am logged in as username. Now I can select the most beautiful, the colorful socks, maybe. Add it to my cart. Let's see if the cart gets updated. Cart gets updated. Go to the cart. It's updated. I have a shipping address. I have payment method. And then I can proceed to checkout. Well, application is working. And that's the state I want to show you today, how easy it is to build up a fully functional microservices web application. And yep, next time there's just the pipelines. I hope you enjoyed the track today.
Thank you so much, Felix. Thank you everyone for joining. You will get the recording within the next 48 hours via email. And along with the recording, the invitation to the next session, which is going to be on Thursday next week, same time as today. So with that being said, thank you so much, everyone, and see you next week.